Hi and welcome to this special edition plugged in webinar as part of World Green Building Week. My name is Lena, I'm the Education and Training Manager here at the New Zealand Green Building Council, and I just want to give you a warm welcome to everyone who is listening to this presentation today, hopefully from a warm, cozy home or office. The case studies we're presenting this week are all about Better Homes NZ, which is the theme of this year's World Green Building Week. Some of you might have listened in to Monday's presentation on 15 Dove Grove by Annabelle Numaguchi, and might also be interested in finding out how Zane Raphael turned a leaky house into a 10 Homestar family home. But today, I'm really excited to have Martin King and Matt Wilson with me, who will tell us how an apartment building in Auckland was awarded the first 10 Homestar in New Zealand. Martin King is an architect and designed the apartment building Daisy, and Matt Wilson was the NZGBC Homestar assessor who assessed the building. Hi, Matt and Martin. You're with me in the room.
Hi.
I hope you can all hear us, and I think most of you are, have arrived already to the presentation, so thanks very much. We'll look forward to finding out what the drivers were for the design of this apartment and what latest greenest technologies and energy-saving features were used to keep you comfortable while saving your money and our environment. But before I hand over, I'm just going to say thanks to our corporate sponsors, Warren Mahoney, APL, Resine and Bailey's, as well as our World Green Building Week national sponsors, Bailey's and Kingspan, and JIB, our webinar sponsor. So I hope most of you are in the room now and all well connected and comfortable. Just a quick house rule, you'll be muted during the presentation, but you can send in questions through the question box. So if you have any questions during the presentation, you can just send them through and we will answer them at the end of the presentation with a Q&A. So Matt and Martin will be able to answer them for you, hopefully. To get a bit of an idea of who's in the room today with us, I'd just like to see if any Homestar professionals might be in the room who are very familiar with our tool, or if you don't know the tool well and haven't had any exposure with us so far. So I'm just going to run a poll for you now. Are you a Homestar professional? Coming up now. And it says waiting for a few more people to vote. Yep, so we've got about 60 people who are not, and about 37 people who are. So 60-40 about in the room, 60 who are not a professional, 40 who are. Interesting. Okay, so I'll jump straight into the presentation then, and welcome Martin, who will start the presentation.
Hi, thanks, Lena. Yeah, so I'm Martin King. I'm one of the in-house project architects at Auckland Residential. We're a development company based in Auckland, specialising in medium density apartments, generally 3 to 6 stories on brownfield sites. As a company, we're committed to quality urban design and architecture with a focus on quality, durable materials. With Daisy, we really want to do a development that was affordable, energy efficient, and provide well-connected urban living. So we saw this as a real opportunity for the project to achieve some high sustainability outcomes. So we hooked up with Matt Wilson to facilitate things and guide us through the process and options. We initially marketed Daisy as a Homestar 9. We thought we'd done pretty well, and we're very happily surprised they've made Homestar 10. It's 6 stories plus basement, and it's located at the end of a short cul-de-sac in city fringe Eden Terrace. Eden Terrace is a small area between Mount Eden, Dominion Road and Kingsland, if you're not familiar with Auckland. It's about 1.5 k's to the top of Queen Street and about 3 k's to Britomart. but 5 minutes walk to Kingsland and Dominion Road, shops and cafes and restaurants. The the site is 321 square meters. There are 33 apartments with a mix of 1 and 2 bedroom units. There's no private parking. However, there are 2 shared communal cars for residential use. The basement houses services, storage, and parking for 12 scooters and 48 bicycles, and access from ground floor and street level via stairs, lift, and a dedicated scooter lift. So here's a list of the Homestar categories that we've addressed, and we'll quickly go through them now, loosely just following the order of the Homestar guide checklist. So with thermal performance and space heating, there's a photo of a typical lounge with a balcony out looking east. The model was, the building was thermally modeled by Thurston Consulting. To minimize heat loss, we used higher than code insulation values in construction elements. Walls were typically, R2.6, the roof was R5, floors minimum R2, and glazing R.26 to 0.39. The thermal model had to be repeatedly fine-tuned and adjusted to find a balance between the desire for heat gain in the winter and to avoid overheating in the summer. It became quite apparent early in the modelling that the heat loss was easily manageable with insulation, but solar heat gain through the glazing quickly pushed the mean temperatures beyond the 25 degrees Celsius comfort zone. So in practice, we basically had to find a balance between making the windows big enough to let light in and be functional, but not making them so big as to cause overheating issues. We also used high performance glazing, which had high shading coefficients to help to keep the energy out but still remain light. And on the balconies, we installed solar blinds for external shading for use when required.
I think I might just jump in there. I think the thermal modelling was a really useful tool. It was something that had been suggested for Homestar 2, and as this project trialled Homestar 3, and Ockham part sponsored the development of Homestar 3, it meant we went through quite a prolonged period of doing thermal modelling to try and get that balance. I think we had about 18 or 20 different versions that we modelled to get to the final version. And while a lot of it was intuitive that north and western glazing was going to be a problem, it was also interesting that some of the eastern areas early morning in summer were getting quite hot quite quickly, and that we were getting an early heat spike in those apartments. So yeah, it's not what you might just think of being just the western and northern being an issue. Eastern potentially could as well. Because it's such a small envelope, it can heat up really quickly. So yeah, that was the largest challenge, to reduce the cooling loads, and in the end the balance is probably in most of the apartments about 25% of the load is heating and potentially 75% is cooling.
Mm-hmm.
So the next slide is hot water system. So typically in a typical house or apartment, you would have a hot water cylinder in a cupboard somewhere, and a cold water feed to it, and then the water's heated and then reticulated around the house. At Daisy, we don't have the 33 individual cylinders. Instead we have a centralized hot water system. So if you have a look at that schematic on the slide, we have heat pumps on the roof that run boilers in the basement that heat a 5,000 litre hot water tank, which acts as an energy storage. Then incoming mains water, that would be the blue line, passes through multiple heat exchange cores in the tank, is heated and then reticulated around through a central ring main, the red line, throughout the building. And at each floor, the individual feeds run direct to each fixture. And these feeds are small bore pipes of 10 millimeter diameter, and they go direct to the fixtures, meaning you get good water pressure and quicker hot water. And as the water is direct from the main supply and is constantly flowing, it does not need to be heated to 65 degrees to kill the Legionella. The water is heated to provide 55 degrees, and because of this, this lower temperature means that heat pumps can perform more efficiently. And each apartment is individually metered and charged by the body corp for the hot water use.
If I can jump in here, this was conceptually a way to try and store the solar energy we were producing and use it for the most efficient way that we could for, I guess, the one aspect of buildings in New Zealand, or residential buildings in New Zealand, that haven't had huge increases in the performance of the systems, whereas heat pumps for space heating have hugely increased the efficiency, and the LED lighting has increased the efficiency of lighting. Hot water cylinders with a resistive coil are very inefficient, and we're getting coefficients of performance out of this particular system of around about 4. So overall, in terms of the energy demand of the apartments, this one measure is probably reducing the overall energy by between 20 and 25%. So I think it's a key achievement of the building. And also by metering both the hot and cold water, it should drive change in user behaviour once they recognise the actual cost of hot water and the cost of cold water as it's metered here in Auckland.
Lighting, pretty straightforward here, just low energy LEDs used throughout. There are motion sensors in the common areas, so lights would come on when they're actually required. Next slide. Whiteware and appliances, there's a typical kitchen in the apartments. Dishwashers and washing machines were energy rated, and they're supplied and installed in each apartment. Renewable energy, obviously solar panels on the roof, 10 kilowatts, providing power to feed the common area lighting. So that's in hallways and lobbies and stairs and services, running the lift, common ventilation being the ventilation to the hallways, common hallways, and obviously to run the hot water as well, we just talked about.
Just like to add also, during the various power cuts with the storm earlier in the year, we understand that the building was out without mains power for 3 days approximately, during which time both the hot water, we continued to have renewable energy driving all those common systems, but it was also helping with the hot water, so people didn't run out of hot water during that 3-day period. So there's a resilience aspect to some of these features as well. That was pleasing that it actually worked so immediately after the building was opened.
Moisture control and heat recovery ventilation. So this photo shows the typical balconies with, you can see the extracts there, the 2 square grills on the front there. In each apartment we have individual heat recovery ventilation systems from German company Zender. So the fresh air comes in from the outside, obviously, through an external vent, and then stale internal moist air is extracted. The fresh air passes through a heat exchange system, and over 85% of internal heat is recovered. This reduces the need for space heating to meet the comfort thresholds of Homestar. Units are continuously ventilating at a very low rate. I'm not sure how many cycles per hour that is, but you basically don't have to open any windows to get ventilation, and you don't lose the heat that's already in the building.
Yeah, I sort of add there as well. I mean, because of acoustic constraints, we couldn't use opening windows as an option for ventilation, so we needed to have mechanical ventilation. But these units are certainly superior to most things that are put into the New Zealand market, and they're recovering anywhere between 85 and 90% of the energy. They're also filtering the air, and that reduction in the humidity levels in there as well also assists in summer to run it on boost, that you're actually reducing the humidity levels in the apartment, which is one of the key comfort things around heat in the Auckland context. So yeah, they're multifunctional.
And there's a boost function that you can use it in the bathrooms for extracting the air from there.
And because it's constantly going, there shouldn't be any build-up of moisture anywhere in the apartment.
The other moisture control features mentioned there, the single piece shower trays, just reduce the risk of leaks. They're stainless steel, it's welded, and floorways, gullies, and bathrooms, and high insulation levels in the building fabric. Sound insulation. That's a photo of the north elevation facing the railway tracks directly below. There was a requirement in the resource consent to provide sound insulation from the railway tracks. So it's a concrete building, so they're pretty well insulated there, but the weak points are double glazing. The windows, obviously, the double glazing was specified by the acoustic engineer and specified to meet the requirement of the resource consent.
I think that photo does show also that we had to minimise that as also the northern facade, or slightly northwestern facade, isn't it?
Yeah, slightly narrow windows.
Yeah, the narrow windows, but there's still really good light levels in there, but we needed to reduce those down because we were getting too much heat gain in the original window sizings.
Yeah, and you can just see the blinds at the top of on the balconies.
So that's another active measure. Each balcony has a blind that can be used by the occupants to enable them to have windows and doors open to get some air, but also to reduce the sunstrike into their buildings.
Next is rainwater harvesting. This is okay. There's a picture of the basement here. I couldn't find a picture of the actual storage tank, but there's a 10,000 litre storage tank collecting rainwater and basically for use in common areas for the garden and for car washing. Next, internal potable water use. Obviously, we've got efficient dishwasher and washing machine and customised basin and sink mixes.
Might just add there, we worked with Methven. The tap style and brand was all selected. It wasn't the highest WELS rated option. However, we worked with them for some special aerators in there to get it up to a WELS 6-star, and some of the team from Ockham went to test those taps just to make sure that at those very low flow rates they weren't actually going to be something that the occupants would find unsatisfying, or they think it should be more water. They were satisfied and not aware of any issues with it. So.
Yeah. Recycling and composting. Dedicated compost bins in the kitchens, as well as standard recycling of normal waste. But the residents take the compost down to the basement. There's a dedicated wheelie bin to be collected for the compost for composting by Green Gorilla, I believe. Waste construction reduction. This photo shows in situ concrete here. 90%, around about 90% of the concrete was cast in situ, including footings, slabs, walls, stairs, balconies, and they all used reusable shuttering. So there's very little wastage from that process. And the remaining concrete was precast concrete, so they were made off-site. And there's a waste management plans provided by the developed by the contractor. So everything was monitored and measured and recorded.
Yeah, so we were monitoring that on a monthly basis to see where it was targeting, and it was always above the level we needed to achieve. And it was pleasing towards the end that it maintained that as the last of the waste came out of the building and all the packaging and so forth.
So material selection. So we work with Firth and to use a eco blend fly ash concrete. So the fly ash is a byproduct of the Huntley Power Station, and was used in the concrete as a reusable product.
Yeah, we worked very closely with Firth, and they were keen to have us as a building as an exemplar and use their eco blend concrete because it's such a large component of the building. It also uses golden base cement, which again it's got measures to reduce its energy profile as well. So there's a double whammy there of effect. And it worked very well.
Yeah, and there are obviously other certification from Pacific Steel, the Jib eco label, and the carpet there.
Yeah, and I'll add there's probably another 20 different things we could have put down there. Yeah. Everything was selected with green credentials. So yeah, that was a key criteria as we went through the specification process.
Again, with the VOC toxic materials, similarly.
Mm-hmm.
stormwater management. This is a photo of the actual excavation on site. You can see a lot of large basalt rocks there. So there's very good soakage there. So 100% on-site soakage. There's no connection to the public stormwater line. So all the rainfall captured on the roof is disposed of or managed on site, and the capacity meets the 50-year event requirements. Native ecology and on-site food production. So the neighbouring site is actually owned by Auckland Transport. So on this plan, you can see on the top of the slide is the actual building, the white bit, and the railway line is to the right there, and Dominion Road's at the bottom of the page. It's probably a bit abstract, but so the site is owned by Auckland Transport and is somewhat neglected. So we entered into an agreement with AT and invested in the landscaping. And this provides green amenity to the residents and the public, as it remains in public ownership. It was previously pretty run down and disused. With our planting, we've increased the biodiversity with a substantial amount of native planting, and vegetable gardens and fruit trees also established for on-site food production. Site selection. So it's very rich in amenities and public transport, cycle lanes, shopping and food. I mean, site's basically 30 seconds to Dominion Road across that garden area, 2 minutes to the nearest shop and restaurant. So yeah, it's very well connected. Bike storage. Yeah, a lot of 48 bikes, 12 scooter parks, and a dedicated scooter and bike lift on the next slide. You'll see. So yeah, you need to get to your bike. You need to get to your bike or scooter somehow. So that worked really well.
Might just add there, I mean, one of the things that obviously controversial about the building was no private car parks, but an impact of that was it opened up those opportunities for the cycles, the scooters, and also the areas for the common hot water and the water harvesting, which we wouldn't have had otherwise. So, and yeah, there's a market for it. It's been sold, and certainly more developments now are actually not having car parks either. Yeah. Some without even the shed car parks. So, you know, it's very innovative in that respect.
Yeah. So on that, yeah, so there's absolutely no car park, on-site car parking, apart from these 2 shared cars. It's quite common for apartments in the city to not have car parks, but not on the city fringe. But the unitary plan allows that we can now. There's no minimum requirement in building mixed use zone, so it's really up to us as the developer whether we want to provide them or not, whether it's actually viable to sell an apartment without a car park outside the city centre. In this case here, I mean, the ground is classic Mount Eden solid basalt, which is very time consuming and costly to excavate, not to mention the noise and vibration associated with that. And the tight site meant it's actually pretty difficult to efficiently design access ramps and parking. And this added cost would just be passed on to the purchaser. So in the end, it was pretty easy decision for us to ditch a car park. But at the same time, we wanted to provide some option for the residents. So a shared car system has been implemented. It's managed by City Hop, and residents can book a car and take it to the beach or whatever they need to do. I think it's a subscription or pay-as-you-go basis. And this lack of cars didn't deter buyers at all. We basically sold down the whole place by opening day. And finally, Daisy, the name. So the apartments are on Akapira Street, and Akapira is a native shrub found around the North Island, mainly around coastal and forest margins. It's known as the New Zealand tree daisy and belongs to the same family as the common English daisy. And daisies are actually composite flowers consisting of tiny hexagonal shaped flowers or florets that form the centre. So the patterning on the building is just a bit of a geometrical play on that pattern. It's formed as a light relief in the plasterwork, so over the course of the day, depending on the angle and the viewing angle, different patterns will become more dominant. So you can see, maybe on the next slide, more apparent the three-dimensional cubes and star patterns, or diamonds or hexagons, will sort of be more visible, more apparent, depending on the light. That one's actually quite a flat photo, so but it continually transforms throughout the day and season to season. So
cool. Thanks very much, Martin and Matt. That was great. I'll definitely take the shared cars and tour through the apartment for myself. Right, so we're moving on to questions. I've seen a few come through already, so we'll do our best to answer them now. A lot of them around thermal modelling, I can see. So why don't we start with that? How did you do the thermal modelling? What is the fee for doing energy modelling? And what thermal modelling software packages were used? Kind of three
Sure.
more.
So, I mean, the modelling was done by Thurston Consultants. I'm not familiar with the program in any detail other than it's IES is the name of the program. We had to split models around summer and winter in different modes with either the shades down or the shades open. Obviously, we were wanting to get the sun in the winter generally, but not wanting to get it in the summer. But it was all done to the protocol that had been developed to generate some figures for each apartment, and there was a reasonable range at different areas of the building. So some performed better than others, and yes, like I said earlier, the balance between cooling and heating was, yeah, significantly different in different apartments, but overall there was a bias towards the cooling requirements. As for the fee, I'm not across that. However, given that we did do lots of alliterations, I can imagine it might have been quite high.
Yeah, I don't have the number on.
But it was a very good design tool, and it certainly gave us some understanding of where we should be putting the effort in for the building to make sure it performed.
Thank you. That was from Annabelle, Anthony, and Nicholas. Now, Louisa is asking, how often are the City Hop cars used? What is the feedback from the residents, if you have any, and does it work well?
I actually don't know. I don't know how any of that actually. Unfortunately, hasn't been any adverse comments. So I mean, that's possible. Yeah.
I think it's beyond the two cars. They've also got a net that can use the network throughout Auckland as well. So I think it gives them some quite broad options, and it was part of the initial package for purchasers to have the first year registration and so forth to, I guess, get used to it. But no, I'm not across, exactly how it's operating. Did you say the
registration for the first year was?
It was part of the package, as I understand it.
Yeah. Oh, okay.
So there was no impediment to sort of start using it. It was there, and you had it. So
that probably helps. And how many people occupy the building?
33 apartments.
It's fully
tenanted or owned. There are 13 two-beddies and 21 bedroom apartments. So yeah, I don't know how the actual occupancy load is at the moment. But.
Oh, good. So no space for me. Anthony's asking how many Homestar apartments typologies made up the development.
There was 9. There was 3 different apartments on the ground floor with some of those other things like the car parks and the entry and so forth, and then the floor plates above the 6 apartments which were typical. Obviously slightly different thermal things happening from the bottom one and the top one, but yeah, they were all made up exactly the same materials and so forth. So
Fatma's asking, hello everyone, and thanks for this valuable webinar. I am interested to know if there is more detailed information about used materials, such as its environmental impacts on life cycle.
And there hasn't been any formal sort of analysis of the building and looking at the things that we put in there, but each individual component, obviously there is that information available. And we made mention in the webinar here about some of those materials, and as I said, there was a whole of a lot more that were actually specified because of their particular certifications, whether it be under NZBC or ECNZ or some foreign one. And some of them also had EPDs. But as a formal, looking at the life cycle analysis of the building, I'd say it's been built to last way more than the 50 years it needs to, and certainly low maintenance, and is a key driver for outcome in their buildings.
Thank you. Melda's asking, were there any airtightness measures within the building envelope to allow the heat recovery system to function so well?
Well, it's all in situ concrete, so and strapped and lined. I mean, it's very airtight, reasonably airtight. It's not,
what I could add there is, I mean, obviously the actual ventilation system can be used in a passive house where you'd be actively looking to limit the air losses, but because it is concrete and we have other controls around smoke and fire as well, that by default actually seals up a building pretty well in that context, and we only have one external wall. But it wasn't specifically something we were looking to do.
Cool. And Annabelle's also asking if airtightness was a consideration at all.
It was a consideration, but it was something that was being relatively well addressed by default. And that we only have one external envelope wall, and all the rest, like I said, is smoke and fire sealed. So that helps compared to a normal construction.
Great. Yeah, some good questions have come through. We're actually at the end of our webinar time now. Roland's asking if he can watch it again, and the answer is yes. I'll send you the slides through as usual. So just a quick let you guys all know what's happening this week for World Green Building Week. We have our Green Room in Auckland tonight. Tomorrow we're in Wellington, as well as Green Speak in Waikato, and we've got a movie night on Friday evening, so come along after work if you're in Auckland, and also another SAMES webinar on Friday on the Super Reno. And the Super Home tours are happening this weekend in Auckland, so come along to those. They're always very popular, and you can see some of the case studies this week on that tour. So jump onto the Super Home website and come along. So yeah, thanks very much for attending. Thank you very much, Martin. Thank you very much, Matt. And everyone have a lovely day. I'll leave a quick survey with you guys to answer if you've got a few seconds. That will be great. Thanks, and see you next time.